So when they say to rotate the shape 180 degrees about the vertex A, that means we're turning the shape somehow around A. That means in this particular problem that A is going to be a fixed point. No matter what I do to this shape, no matter how I turn it to create my rotation, this point A is always going to be at that exact location. B and C might move around, but A ain't going anywhere. Alright, so we're supposed to rotate the triangle 180 degrees about vertex A. So, the corresponding sides here are going to end up lying on a straight line. And that line is the x-axis here, at least in terms of AB and A minor, B minor. How do I know that? Well, let's take a look. Let's say here I want to start at A, which I do because that's the point that's fixed, and I want to run towards this point out here, which is the point C. Okay, AC is pointing to the east right now. I have to turn it 180 degrees. Well, if I'm turning it 180 degrees, that means it's going to be pointing the opposite direction. So instead of facing east, it's going to turn and it's going to be facing west now, because 180 degrees, that's half a revolution here. So instead of facing east here, it's now going to be facing west. But just because I'm turning it doesn't change its length. And I know that this point A is still going to be here when I'm done. So if we take a look at this point out here, it's 1, 2, 3, 4 jumps from A to get to this point out here. Well, the new one's still got to be 4 jumps from A, but facing west, because it's making, again, 180 degree turn. That's half a circle going from east to west. So I'm going to make it go 4 jumps away, 2, 3, 4 jumps away from A going the other direction, and there's my new point. All right, and again, here's that line they were talking about. All right, now as far as B goes, B, not really all that much trickier, but we just have to think about it a little bit more. B right now is on the north side of the illustration. When I take and turn B, if I'm going to take and turn it 180 degrees, if it's pointing north, that means now it's going to be pointing south, straight south. So I know where it's going to be. Now, the problem is I can't just take and turn it and say, oh, just drop it straight down and make it face south. Because remember, the triangle is turning around this point, so it's now gone, as you can see, over here. So when I turn it, it's also got to come over this way, over here. All right? So take a look at this point here. All right? How do we figure this out? Well, compare everything to A, because that's not changing. It's 1, 2 jumps on the x-axis to A, and then 1, 2, 3 up. So the new guy's got to have the same thing. So start at my new A, I'm going to go 1, 2 jumps away, and then 1, 2, 3 to the south now instead of the north. All right, and that's where my new point B is going to be. All right, now I know where A and B and C are, so now I'm going to go ahead and connect those points. Okay, as you can see, there's another line they were talking about. And as we draw this out here, here's my new triangle. Exactly the same triangle, just happens to have been turned 180 degrees. A, as this is drawn here, ends up being the midpoint of this whole set here. A here is exactly halfway between the old triangle and the new triangle, because there's 4 units on either side of A. The midpoint is simply the point that's halfway in between any 2 given points. If you're having a hard time visualizing this still, what might be best for you is to take and sketch out whatever you have on a sheet of just regular paper, cut it out, and then picture yourself actually turning it. Not everything's going to be 180 degrees. Sometimes they're going to say 90 degrees clockwise. Sometimes they're going to say 270 counterclockwise. You've got to sit there and do the same thing to figure it out. You know that 90 degrees is a quarter of a turn. So if I'm asking you to turn something 90 degrees and it's facing up, 90 degrees is all of a sudden going to be facing east. If I tell you something's facing up and I tell you to change it 270 degrees, that's 3/4 of a turn. We know 90 is here, 180 would be down, so 270 would be facing west. Again, it's just a matter of doing that. They're not going to give you something really complicated like turn it 36.8 degrees. That's not what they're doing here. They're looking to see if you understand the idea of a rotation, not how complicated they can make the question. Alright, so let's go ahead and take a look at the concluding examples here. In the concluding examples, number 1, they're asking me to identify the type of transformation here. Alright, what transformation is being sketched? Well, if we look at number 1 here, we have two quadrilaterals, specifically two isosceles trapezoids here, and we're supposed to figure out what is going on here. Now, even though they've given one very specific answer, there's actually two answers that could work here. Because these shapes are the same, it creates two unique possibilities here. This could be, as they've indicated, a translation, where they took this shape over here, this trapezoid on the right, and slid it to the left. That would make it a translation. They could have also created a mirror image here, because notice, because this is an isosceles trapezoid here, everything has the same aspect ratio, just looking at one shape and then comparing it to another shape. For instance, this point here is not any distance away from the y-axis, so that's all the same. This point here, one jump away from the y-axis, 1 point jump away from the y-axis, all the same there. As we look at this point here, 4 away from the y-axis, 4 away from the y-axis. We've seen this as we've gone through this before. It does create for us two possibilities. It could be a translation, or it could end up being here a reflection, a mirror image of the original shape. In number 2, they're asking me to graph the translation of quadrilateral ABCD 5 left and 3 down. So again, that means we're going to take and slide every corner 5 left and 3 down. And as you can see, that's already sketched here on the page for us. So we start with A and we go 1, 2, 3, 4, 5 left and 1, 2, 3 down, and there's my new A. With B, we do the same thing. Go 1, 2, 3, 4, 5 left and 1, 2, 3 down, and there's my new B. With the point C, we go 1, 2, 3, 4, 5 left and 1, 2, 3 down. And with the D point, we go 1, 2, 3, 4, 5 left and 1, 2, 3 down. And there's my new quadrilateral, the image, the after ABCD.